All right, everyone. Let's begin then. Ibrahim, the most important thing that you need to keep in mind is that you don't get stuck at a question. That's the most important thing. And then go through the paper once. Take a couple of minutes. Go through the paper quickly once to have an idea of what's coming, and start with the relatively easier questions. That the questions that you find easier, start from those first, and try to do them as quickly as possible, and then for the difficult questions, leave enough time for the end. So try to get done with some of the easier topics first, like partial fractions, binomial, iteration, uh, modulus, uh, con- uh, in paper three. So basically topics like these, and then gradually increase the difficulty level. And do not get stuck at a question. That's extremely important, because that is what ends up being the most important factor in you finishing the paper in time or not. That you do not get stuck at any one question. If you can't figure something out in a few minutes, move on. It's all right. If you're finding something difficult and you're well prepared, it's very likely that most of the other people would have found that difficult as well. Make sure that you do all the questions correctly that you do know about, and then come back to any questions that you skipped at the very end. Do not spend too much time in the middle on any one particular question. That's what takes that's what ends up taking most of the time if you uh, start doing a question like that in the middle. That makes you panic later on as well, because even if the rest some of the other questions are easier, and you're thinking that you're running out of time, you'll start panicking, and that will make you lose even more marks. So that is important, that you don't get stuck. Now let's begin with this. uh, okay, so November 2022, paper 3-1 and 3-2. We want to do difficult questions from these two papers today. That's the plan. Now, let me have a look at the questions that you've asked from these two papers. Make sure that you've responded to the polls already. I can see some responses, but there's still not as many as I would have expected. So please make sure that you've looked at the papers once. If not, if you haven't attempted them yet, at least have a look at the papers and let me know which questions look difficult to you, so we can have a look at those questions. So first of all, let me begin with this paper, November 22, paper 3-1. Let's start with this. So the first question that you're asking about is the very first question. Question number one, why this, by the way? Paper 3-1, is this the correct paper? November 2022, okay. What's the problem with this modulus question? Okay, so it says sketch the graph of y equals modulus of 2x plus 1. Now, how do you draw the graphs of modulus functions? All you have to do is find the vertex. The modulus graphs look either like this or like this. These are the graphs that you have in your syllabus, either V shape or inverted V shape. These are the only two possible shapes that you would get. What you do is you find the vertex. Where is the vertex going to be? Vertex is when the part inside modulus is equal to 0. 2x plus 1 equal to 0. What does that give you? X equals minus 1 over 2. This is an important point that you have to show on the graph. Okay. X equals minus 1 over 2. What's the corresponding value for y that you get for this? Y is equal to 0. Okay. When x equals minus 1 over 2, y is 0. Now, all you have to do is draw x and y axes like this. And you say, this is one point that you've got on this graph. This is y-axis. This is x-axis. Let's mark that point. This is 0. So minus 1 over 2, let's say this is minus 1. This is minus 2. And then 1 on the right side, 2 on the right side. At minus 1 over 2, you've got this point. This is going to be the vertex. Now you just take 1 point to the right of it, 1 point to the left of it. So this is x equals minus 1 over 2. Take 1 point to the left. For example, x equals minus 1, x equals minus 2. Let's say x equals minus 2, for instance. What's the value of y that gives you? If you input x equals minus 2, that gives you y equal to 3 here, right? It will be minus 3 modulus, which becomes 3. So when x equals minus 2, one point that you're getting here is 3. Let's mark 3 somewhere here. So we've got 1 point here. At -2, it's 3. And then put another point. So maybe if you put 1 here, you get 3 at 1 as well. And now you just start from the vertex, draw a line in this direction here, and draw a line in this direction here. That's your modulus graph. Make sure that you're using a ruler for this. Let me see if this works for me. Yeah. So this is what it's going to look like. On one side, on the other side, it's going to look like this. This is what the modulus graph looks like. So you start from the vertex, take 1 point to the left of it, take 1 point to the right of it, and then just join those points like this. That's your graph. Now in the second part, it says solve this inequality. Now for this, you've got a standard method. What's that method? You treat this as an equation, first of all. So you say this is 3x plus 5 equal to modulus of 2x plus 1. Treat this as an equation. Now remove the modulus sign, put plus minus on any one of the two sides. So remove the modulus sign, put plus minus on any one side. Let's say I put that on the right side, plus minus 2x plus 1. Now you split it into two parts. You say this is 3x plus 5 equals 2x plus 1, or 3x plus 5 equals minus into 2x plus 1. You just solve these two equations, you will get the critical values of x that you're going to use here. Let's see what they turn out to be. In the first case, you get x equal to -4. In the second case, you get 3x plus 5 equals minus 2x minus 1, which becomes 5x equals minus 6, and x equals minus 6 over 5, or minus 1.2. This is what we're getting here. Now, these are two important points that you are going to consider when you think of which regions are going to be correct. Now, what you do is you draw a number line like this, mark these points on this number line. This is the standard method that works for every kind of modulus inequality, and in fact for other inequalities as well, for polynomial inequalities like cubic inequalities as well. Just find these cutoff points and now represent them here. -4 is the smaller number, that's going to be here. Minus 6 over 5 is the bigger number amongst these two numbers. Minus 1.2, that's a bigger number. That's here. These are two cutoff points. Now, all you have to do is take 1 point in each of these regions. One region is to the left of -4, one is between -4 and -6 over 5, and one is to the right of -6 over 5. These are three regions that you've got on your number line. Take one number in each of these regions. Take one number to the left of it. On the left side, let's take -4 for instance. On the left side, let's take -5 for instance. Let's say -5 here. In the middle, take one number. Between -4 and -6 over 5, what number can we take? Let's take -2 for instance. And on the right side, take one number, 0 maybe, right? But that's bigger than -6 over 5. You've got these three numbers. Now just check them in that inequality. 3x plus 5, that's less than modulus of 2x plus 1. And see what that gives you. If you input -5 there, let's see what we get from that. 3 into -5 plus 5, that's less than modulus of 2 into -5 plus 1. What does that give us? On the left side, we've got -15 plus 5, which is -10. That is less than -9 modulus, which becomes 9. Is this correct? Yes, this is correct. So this region is correct. Let's try -2 now. If we try -2, that gives us 3 into -2 plus 5. That is less than modulus of 2 into -2 plus 1. What does this give us? The middle region. Let's evaluate this now. On the left side, we've got -6 plus 5, which is -1. -1 is less than, what's this? -4 plus 1, that's -3. -3 modulus is 3. So -1 less than 3. Is that correct? Yes, this is also correct. Let's try the number on the right side. What does that give us? 3 into 0 plus 5, that is less than 2 into 0 plus 1, modulus of that. On the left side, we've got 5. 5 is less than 1. Is that correct? That's not correct. So the middle region is correct. The region on the left is correct. Is it -3? On the right side, there's modulus LIBA. So modulus of -3, that becomes +3, right? On the right side, we've got, in this region, we've got 5 less than 1. So that is incorrect. So the middle region is correct. The left region is correct. The region on the right side is incorrect. So what's our solution then? All of this region, right? Middle region is correct. The region on the left is correct. That's one big region. It's a single region. You will write that as a single inequality. You would say the answer is x less than minus 6 over 5. And that should be the final answer that you write here, x less than minus 6 over 5. Is that okay? Any problems with this? So what exactly was the question here? That's the standard modulus inequality question. There was nothing complicated here. Yes, Divya, you need to have the same distance between points, not necessarily with a ruler. So if you're drawing this graph, roughly it should be the same distance. So if this is 1 unit, it should be the same distance here as well, roughly speaking. Don't draw something like this, that you have 1 here, and then you have 2 here, because that does not make sense, right? It should be roughly accurate, right? You can't have 1 here and then 2 here, because 0 to 1 is a very small gap here, and then 1 to 2 is a very big gap here. So at least it should look all right, okay? You don't necessarily have to use a ruler for this, but just by looking at it, the distances between corresponding points, they should look like they are roughly the same. Okay. Any problem with this? Any questions, anyone? Do not use the quadratic inequality method here. That does not work. Okay. Do not solve it like a quadratic inequality. You can do that when you have modulus on both sides. But when you have modulus on one side, then you have to check on the number line like this. Okay. No problems? Okay, let's move on. Now, let me have a look at the next question that you asked about from this paper. Okay, so the next one is question number 5. I'll just go through the rest of the paper very quickly. The questions in the middle. We've done these questions multiple times, right? You know how to draw this. Modulus of z being less than or equal to 3, this is going to be a circle. I'll just tell you, it's going to be a circle. Radius 3. This will be the radius. Center will be at the origin. Okay. And all the points inside the circle, they are going to be valid according to the first inequality. And then this means real part of z is greater than or equal to -2. Real part is on the x-axis. What that means is x is supposed to be greater than or equal to -2. So you would draw a vertical line, x equals -2 line. It will be a vertical line, and you have to be to the left of that line. So within that circle and to the left of this line, that's the second condition. And then the argument has to be between pi over 4 and pi. You will draw those two lines, one at an angle of pi over 4, one at an angle of pi, and you have to be between those two lines. Okay. Now, not many people have asked about it, so I'm assuming that you would be able to do it, right? Just have to shade that region then. Is that doable now, Devya? You were one of the people who asked about it. You can do that now. Is there a specific problem that you have in this? Shouldn't greater than -2 be on the right? Yes, you're right. I'm sorry about that. You're actually right. It's greater than or equal to -2. So it should be on the right side, yes. You're right about that. So you have a circle. You have to be within that circle, and then to the right side, and then when you draw those two lines, you have to be between those two lines. Okay, I'll do that. Okay, so other people are also asking about this now. So let's do this quickly. This is what the Argand diagram looks like. This is the imaginary axis. This is the real axis. Modulus of z less than or equal to 3. What does that mean? You have your center at the origin. Radius of the circle has to be 3. So you would draw a circle of radius 3 here. Now let me draw the circle here. And we're saying this point is 3, this point is 3, this point is -3, and this point is -3. Okay. This is one locus that we've got, a circle with center at the origin, radius 3. You have to be within that, inside the circle. And now x is less than x is greater than or equal to -2. What's that line? X equals -2 line. That's a vertical line, right? So you draw a vertical line here. Let me draw that on the side here, and then just copy that there. So this line is going to look like this. It will be x equals -2. So that's -3. -2 is going to be somewhere here. Let's say this point is -2. You have to be to the right of this line, within that circle, inside that circle, and to the right of this line. That's what this means. And then the argument of z has to be between pi/4 and pi. Now, where do we measure argument or angle from? We measure angle from the positive real axis. This is where we're going to measure angle from. Now, the angle has to be between pi/4 and pi. Now, what's pi/4? Pi/4 is basically a 45-degree line. So when you draw this, you have to be careful. It should pass through exactly at an angle of 45 such that this distance is the same as this distance. Okay, whatever is the distance horizontally, it should be the same distance vertically. And this line is going to look roughly like this. Okay, I just draw that again with a ruler. You should use a compass, ruler for this. Try to make your diagrams reasonably accurate, even if it's a sketch. Okay, this is what the 45-degree line, let's say, looks like. Pi/4 line. Okay, this is the angle pi/4. And then the other limit for the angle is pi. Where is that going to be? Start measuring from the positive real axis, pi radian. That will be on the left side here. That will be here. This is pi radian. This is the line that represents pi radian. You have to be between these two lines. Between these two lines. So what's the region that satisfies all of these conditions now? Here and here. This is going to be the shaded part that satisfies all the conditions inside the circle to the right of the x equals -2 line. And then between those two green lines that you have drawn, this is going to be the shaded part that satisfies all of those conditions. Is that okay? Make sense? No problems? Okay, good. That was question number 2. Let's move on to the next one. Question number 3, nobody asked about this. Okay, you have to solve this equation. Take log on both sides, use the multiplication in order to split it, and then you can find it. Make sure to give an exact answer, because it says ln A over ln B. It should be exact. Okay, don't write decimals. Then you have this equation. Okay, so no problems in this as well. So the next question that you've asked about is question number 5 from this paper. Let's have a look at that now. Question number 5. Okay, it says the complex numbers u and w are defined by u equals this and w equals this. Find u square over w, giving an answer in the form r e raised to power iota theta, where r is greater than 0 and theta is between -pi and pi. Give the exact values of r and theta. Now you just have to divide these two numbers, u square and w. Okay, let's do that. Let's actually evaluate u square first. 2e raised to power pi over 4 iota. You have to square this. What does that give you? 2 squared, that's going to be 4. Power gets multiplied with this power, right? 2 into pi over 4, what's that going to give you? Pi over 2. Pi over 2 iota. Okay, that's u squared. Then w is already given there. So what is u square over w going to be like? 4e raised to power pi over 2 iota divided by w, which is 3e raised to power pi over 3 iota. And now you just need to simplify this. What do you get from this? 4 over 3. You want an exact answer? You want exact values of r and theta? So you would leave it as it is, okay? 4/3. What happens to these powers? Bases are the same. If bases are the same and there's division happening, the powers get subtracted. So it becomes e raised to power pi/2 minus pi/3 iota. Now just evaluate this on your calculator and see what that gives you. It should be pi/6, right? 4/3 e raised to power pi/6 iota. That is the result that you get from this. Okay, now if you want to write down the values of r and theta, you can do that. What's r now? R is 4/3, and the argument theta, that is pi/6. You just try to convert it to this form. Okay, pretty straightforward. Just have to use some indices rules. That's what we get. Now it says state the least positive integer n such that both imaginary part of w raised to power n equals 0 and real part of wn is greater than 0. Okay, so how do we think about this? What's w? W is 3e raised to power pi/3 iota. Right? That's what w is. 3e raised to power pi/3 iota. Now, what they're saying is, if we take some power of w, how can we get the imaginary part equal to 0 and the real part positive? Now, how do we think about this? How can we have the imaginary part 0 and the real part positive? One way to think about this could be thinking of the Argand diagram. This is the real axis, and this is the imaginary axis. Okay. If the imaginary part of that is 0, what does that mean? Where is this complex number going to be on this Argand diagram? Can you think about that? If this is what the Argand diagram looks like, and the imaginary part of Wn, w raised to power n is 0, it's going to be on the horizontal axis, on the real axis, because the imaginary part is 0, so it has to be on this line, on this horizontal line. Okay, and then it says that the real part of w raised to power n, that has to be positive. So not only is it on the horizontal line, it's also that the real part is positive. That means it has to be on the right side of this line. So that point, w raised to power n, it has to be on this side, on the right side, on this line. Now, how can w raised to power n be here on this line? What's the argument at this line? What is the argument at this line? Argument at this line is 0, right? How can we have an argument that is 0? Let's think about it. Right now it's pi/3. Pi/3 is going to be somewhere here. This is pi/3. W raised to power n means we have 3e raised to power pi/3 iota whole raised to power n, and that gives us 3 raised to power n. That's going to be the modulus. That's not what we are concerned about. And then e raised to power pi/3 times n iota. How can this number w come to this horizontal line? When its argument, this part, becomes equivalent to 0, basically. When the argument becomes 0. How can the argument become 0? It's on this line, the argument, you can say it's 0, or if you go one full circle, it could be 2 pi, or it could be 4 pi, and so on. How can this number come back to 0? What number do we have to multiply pi/3 by to get 0 or 2 pi? Now, they're saying n has to be a positive integer. If it has to be a positive integer, we can't say that value of n is 0, right? Otherwise, we could say n is 0, and that would give us this a point in this line. After 0, how else can we get an argument that falls on this line? We can say pi over 3 times n, that should equal 2 pi, right? Because when you have an argument of 2 pi, that's also going to fall on this horizontal line, right? Because this is pi, and then this is 3 pi over 2, and then you go back here, that becomes 2 pi again. How can you get 2 pi there? What's the value of n that gives you? 2 pi into 3 divided by pi, that gives you 6. This is the value of n that you get when the imaginary part becomes 0. All right. You could have the value of n 12 as well, or 18 as well, or 24 as well. Basically, when you multiply it by 6, it comes here. When you multiply it by 12, it completes one full circle and then comes back again. And then similarly, it keeps coming back like this. So n could be 6, 12, 18, 24, and so on. What's the least possible value of n? The least possible value of n that we get here is 6. That is what makes the imaginary part equal to 0. Okay? Is that okay? That was question number 5 from this paper that you asked about. Now, the second part of this, that was kind of tricky because it was different from the usual questions that you get in complex numbers. Now, let's have a look at the next one. Okay, so no one has asked about question number 6. I'm assuming you should be able to do it. Cos 4 theta, how do you expand that? Let me just give you a hint about that. You would have to use the double angle identity for cos, right? So if cos of 2a is 2 cos square a minus 1, now what that means is if the angle on the left side is 2a, the angle on the right side is half of that. So what about cos of 4 theta? This would become 2 cos square 2 theta minus 1, whatever is the angle on the left side. The angle on the right side becomes half of that. Okay, so cos 4 theta is going to be this. And then you'll have to simplify this further because on the right side, you've got theta. You don't have 2 theta here. How do you simplify this further? You can write this as 2 cos 2 theta whole squared minus 1. And then you apply the double angle identity inside this again. That will become 2 cos square theta minus 1 whole squared minus 1. Then expand this thing. That becomes 4 cos raised to the power 4 theta minus 4 cos square theta plus 1 minus 1 outside. I've just applied the a minus b whole squared identity here to expand it. A square minus 2ab plus b squared, and that's what it gives me. Then you simplify it further. That's going to give you cos 4 theta. Similarly, you expand cos 2 theta as well. Simplify everything. You will get this eventually. All right. So again, not many people have asked about it. So I'll just skip this, the rest of it. I hope you should be able to figure this out after this. The second part is just using that identity then to solve this equation. In this case, make sure when you do, for instance, now this identity was that cos 4 theta plus 4 cos 2 theta plus 3, that's identical to 8 cos raised to the power 4 theta. What that means is here you only have this thing without the plus 3. So if you were to add 3 here on both sides, cos 4 theta plus 4 cos 2 theta plus 3, on the right side you would have 4 plus 3. So you would get 8 cos raised to the power 4 theta equal to 7 here. Keep that in mind, that in the identity that you proved, you had a plus 3 there as well. So if you want to use that, you would first need that plus 3 in that equation as well. So you add plus 3 on both sides like this. And then you replace this thing with 8 cos raised to the power 4 theta. And then when you have to take root there on the other side, again, do not forget to put plus minus. On the other side, you'll have plus minus and then 4th root of 7 over 8. And then you can do it. It should be in all 4 possible quadrants, but then it's the interval is from 0 to 180. So you would consider the first and second quadrants. You'll get 2 answers for this. All right. So make sure to put plus minus there. Do not forget plus minus. Again, not many people asked about it, but I just thought to explain this in case it helps. Now, let's move on to the next one. This is the next question that most of you have asked about, question number 7 from this paper. Okay, let's have a look at this now. Question number 7. It says the equation of a curve is y equals x over cos square x for x between 0 and pi over 2. At the point where x equals a, the tangent to the curve has gradient equal to 12, so that a equals this. Now, this is one potential part where you can end up getting stuck in the exam. That often happens in problems like these, the first part of iteration. They're often quite complicated, and it looks complicated here as well. So in case you can't figure it out in a couple of minutes, it's a 3-mark question. So if you spend 2-3 minutes on this, make sure to move on. Do not end up remaining stuck here, okay? But don't skip the whole question. The second, third parts of this are generally very easy. This is very straightforward, and this is very straightforward. These are free 5 marks. Don't skip these. Don't leave them for the end as well. In case you end up not having enough time at the end, do not leave these parts for the end. Definitely do and part C. But if you can't figure out part A in a few minutes, for sure, skip that. Come back to that at the end. Okay, now let's have a look at this. The equation of a curve is y equals x over cos square x for x between 0 to pi over 2. Okay, so this is the equation of the curve. At the point where x equals a, the tangent to the curve has gradient equal to 12. If the tangent to the curve has gradient equal to 12, what that means is the curve also has gradient equal to 12, right? Because the gradient of the tangent to a curve is the same as the gradient of that curve. So all you have to do is find the gradient of this curve. How do you find gradient of a curve? You find the derivative, right? dy over dx. Let's differentiate this. dy over dx. And then put that equal to 0, because we're looking for the stage, the point. Sorry, I'm sorry, not put that equal to 0. Gradient is supposed to be equal to 12. So you put dy over dx equal to 12 in that case. Okay, that's what you would do. When x equals a, dy over dx would be equal to 12. That's what you do. But let's first find dy over dx. How can you do that? It's a fraction. We use the quotient rule on this. U over v, what's the derivative of that? V square in the denominator, and in the numerator you have vu dash minus uv dash. Let's differentiate it using that rule. So dy over dx equals, in the denominator, v squared. That means cos raised to power 4x, right? It's cos square x whole square. That becomes cos raised to power 4x. And then in the numerator, you want vu dash. What's vu dash? V is cos square x multiplied by u dash. What's the derivative of x? Derivative of x is 1 minus uv dash. That means u as it is. What's u? U is x into derivative of cos square x. What's the derivative of cos square x? How would you differentiate this? It's a power function. Cos square, that's a power function. You can think of cos square as this. Let me write that on the side. V is cos square x. That means cos of x whole squared. How do you find the derivative of v? You would apply the power rule here. Multiply by the power. Subtract 1 from the power. So it becomes power 1. And then you multiply by the derivative of the base of this power. What's the derivative of cos? Derivative of cos is minus sine x. That is what you multiply by. Here you say this is 2 into cos of x into minus sine x. This is dy over dx using the quotient rule. Okay, once you've got to this point, now you say when x equals a, we know that the tangent to the curve, that means the curve, has a gradient equal to 12. So when x equals a, dy over dx equals 12. Let's put that and see what that gives you. That gives you 12 equal to cos square a minus and minus, that becomes plus. So you've got 2 sine x into cos, sorry, a, to sine a into cos of a divided by cos raised to the power 4a. This is what we're getting. All right. Now let's multiply this denominator on the other side and see what that gives you. That gives you 12 cos raised to the power 4 times a. That equals cos square a plus 2 sine a into cos of a. And now you somehow need to get to that point. Okay. Now, how can we do that? Let's think about this. First of all, they're taking cube root here. Let's backtrack a little from here to try to understand where this form is going to come from. You have a cube root here. And you have cos inverse here. So what will be the step just before this? So sometimes when you have to prove something, you have to think about what are going to be the last couple of steps. So you can think about, okay, this is the form that you want at the end. So this is cos inverse of this whole thing. So just before this happens, you would have something like this. Cos of a equals cube root of cos of a plus 2a sine a divided by 12. Cube root of this. And then if you take cube on both sides, that gives you cos cube a equals cos of a plus 2a sine a divided by 12. Now this is just to get an idea about what exactly you want to get after this step. So you want to get to that step somehow now. Okay. Now what can we do for that? Let's think about it. Okay. By the way, I'm just thinking about this a that's appearing here. Are we missing a potential a somewhere here? Let me just check my working again. Cos per a, no, it doesn't look like it. 2x, yeah. So this x, I missed that because you see you have an a here as well. So we needed to have some a here with 2 as well. So when we wrote this here, in this step, there was also an x here. Let me write that down. It actually becomes 2a into sine a cos a. And this also becomes 2a into sine a cos a. Okay, so that's what we had in that step. Now, what does this become? Now think about this. You want to get to that stage. Now there's no cos raised to power 4 there. There's only cos cube there. So what you can do is you can divide the whole equation here by cos of a to get rid of cos of a, right? Because cos can be taken common from every single term. You have cos a here, you've got cos a here, you've got cos a here. So if you divide by cos a, the whole equation by cos a, that gives you 12 cos cube a equals cos of a plus 2a sine of a. What I've done is I've divided the whole equation by cos of a. Now, why can I do that? Generally, when you have an unknown, you don't divide by that because what if its value was equal to 0? Here, the value of cos cannot be 0 because of the interval that we're given for x. X is between 0 and pi over 2. Cos is 0 when the value of x is pi over 2. And that is not included in the interval that we're given. So we are safe as far as division by cos is concerned. We can divide the whole thing by cos. That's what we have done here. We have divided the whole equation by cos of a. And now we're getting close to that, right? We can write this as cos cube a equal to cos of a plus 2a sine a now. In the denominator, we have 12. Now we can take cube root on both sides. So it becomes cos of a equal to cube root of cos of a plus 2a sine of a divided by 12. And then you take cos inverse on the other side to get this form that they wanted from us. It becomes a equals cos inverse of cube root of cos of a plus 2a sine of a divided by 12. And that is going to give you, that actually gives you the final result that you wanted. You've gotten to that exact form that they wanted from you. Okay, so backtracking a little like this helps you understand the steps that you might need to take to get to that final result. All right, so that's what we do here. Make sense? Yes, Fardeen, you're right. You could also do that. That's actually a better way of doing this. But in this case, we could actually skip doing that. So what it's saying is, here we could have taken cos A common, right? Take everything to one side and take cos A common. On the other side, you would have 0, and then you would say cos of A equals 0. That will be one thing. And then the other factor equal to 0, that will give you this thing. And then you would say this is not possible. Why? Because in the interval that we are given, cos is not 0. Okay, that will be a better way of doing this, although in this case makes it slightly longer. But you can do it like that as well. That's what you should do in most cases. In this case, we could get away with this division because cos could not be equal to 0 within this interval. Okay, all right. Now that's what we get at the end. No problems with this? Okay, good. Let's move on to the next part now. It says verify by calculation that A lies between 0.9 and 0.1. Now, how do we do this verification? We've got this equation in the previous part. You can use that here. Take everything to one side. So remember, for proving things like this, you want a form that looks like this. F of x equals 0. In this case, the variable is a instead of x. So it's f of a equal to 0. You want this thing somehow. Okay. Now, how can you get this? How can you get f of a equal to 0? How can you get f of a equal to 0? You want everything on one side. So it becomes a minus cos inverse of cube root of cos a plus 2a sine of a divided by 12. On the other side, you have 0. Okay. And now you put those two values, you say this is f of x. Or f of a in this case, in fact. Put those two values. Put 0.9 inside this and put 1 inside this and see what that gives you. See what you get at 0.9 and see what you get at 1. Can anyone try this for me? What do you get at 0.9 and what do you get at 1? Make sure your calculator is in radian mode. If we put 0.9 here, let's see what we get at that point. 0.9 minus cos inverse of cube root of cos of 0.9 plus 2 into 0.9 into sine of 0.9, and then that whole thing divided by 12. So make sure that you're not making any careless errors like me. Is this all right? Sine of 0.9, 2 into that, and that's also fine. Cos of 0.9, and that's this bracket here. Okay, so this is giving me minus 0.084. Anyone else getting the same result from this? I'm getting minus 0.0846 for this at 0.9. Okay, good. And what about 1? At 1, I'm getting cos of 1. Now it's actually a bit tricky to put all of this in your calculator all at once. This is giving me 0.0358. Yeah, so 0.0358. The first value is negative, the other value is positive. What do we say? We say the sign is changing. That means A lies between 0.9 and 1. Okay, and that's our final result. Okay, that's the second part. Now let's look at the third part. Use an iterative formula based on the equation in part A to determine A correct two decimal places. Now again, this is what the equation looks like. You would make an iterative formula for this. A(n plus 1), that becomes cos inverse of cube root of cos of an plus 2an. You should write this iterative formula here into sine of an. And in the denominator, you have 12. Okay. Cos inverse of this, and you have cube root here, cos inverse of cube root of this. Cos of an plus 2a sine an over 12. This is what we've got. Now, what value do we start from? The midpoint of these two numbers, 0.9 and 1. This is going to be our A1. A1 is 0.95. The midpoint of 0.9 and 1. So this is going to be our first value. Okay. A1, that's 0.95. Now let's put this inside this formula and see what that gives you. Now let me try this here in front of you. Because putting this whole thing on our calculator is slightly tricky. So I'll just show this to you as well. Let's see if it works. I found this nice app that I can show you here. How you're going to put this here. Make sure your calculator is in radian mode first of all. So it has to be in radian mode. Now let's input that whole formula here and see what that gives us. Cos inverse of, so this is how we start, cos inverse of cube root. Now we have a cube root here. Now you need to input a fraction inside, so press the fraction button. In the numerator, you want cos of an. Instead of an, you should put answer there. Okay. In fact, I should have started from that. I'm sorry. So first of all, you actually put 0.95 and press the equal button. It saves that number in the answer button. And then you start inputting that formula. Cos inverse of cube root of, then you have a fraction, cos of answer. In place of an, you should input answer there. And then plus 2 into answer multiplied by sine of that answer. All right, that's what we've got here. In the denominator, we need to have 12. Now, is the bracket closed? No. Let's close that bracket. And that should work. Let's press the equal button now. This is what we get for A2. Okay, A2 equals 0.9743. You want 4 decimal places, that's A2. What's A3? Let's press the equal button again. That gives me 0.96936. You have to round it off to 9694. Press the equal button again. A4 turns out to be 0.9704. Again, rounding off the last digit. Press the equal button again. It becomes A5, that is 0.9702. Again, round off the last digit. You need 4 decimal places. The last digit has to be properly rounded off. This is what we get. And then let's do it once more, although it's fairly stable now, to 2 decimal places. This also becomes, A6 also becomes 0.9702. Your final answer has to be correct to 2 decimal places. So you say A equals 0.97. And that is your final result to 2 decimal places. Okay. That's what we had to put there. That's how you would calculate this. Make sense? That's the value of A that we get, 0.97. Answer is here, Mariam, when we input 0.95 in the beginning, 0.95, and press the equal button, it saves this number in the answer button on a calculator. And then we use answer in our formula. Answer is here, bottom right, the button next to the equal button right here. Okay. All right. So that's how this works. Now, that was question number 7. Now, the next one that you're asking about is question number 8. I need to take a short break. I actually need to switch my switch to another place, basically. So just give me 3-4 minutes, and we will resume in 3-4 minutes then. Okay. The next question is question number 8 that we want to discuss, but I'll need a break, 3-4 minutes, and then we resume after that. Okay. Okay, everyone, let's resume. Can someone please confirm if you can still hear me and also see my screen? Okay, good. So this is the next question that you've asked about. In fact, my phone has also turned off. But this was the next one. I'll wait for it to turn on for the next question. We'll start this for now. Okay, so question number 8. Let's start with this next one now. It says in a certain chemical reaction, the amount X grams of a substance is increasing. The differential equation satisfied by X and T, the time in seconds since the reaction began, is dx over dt equals this. Now, K is a positive constant. It's given that X equals 20 at the start of the reaction. The start of the reaction means when T equals 0. Okay? When T equals 0, X equals 20. That's what we're given. Now it says solve the differential equation obtaining a relation between X, T, and K. Now, how do you do that? First of all, you have to separate the variables. What does this become? Bring X to the left side. So you have 1 over X into dx. And on the right side, you have K e raised to power minus 0.1 t into dt. K you can keep on any side. It's a constant, so it doesn't matter which side it's on. It could be on the left side, it could be on the right side. It does not make any difference. And now you can integrate both sides. Now that the variables are separated, let's integrate both sides. What's the integration of 1 over x? ln x. On the other side, you have k e raised to power minus 0.1 t. K is a constant that remains as it is. E power minus 0.1 t. What's the integration of that? E raised to power minus 0.1 t divided by minus 0.1, which is the derivative of this thing. Then you have a plus c here. That's the integration part done. Now let's simplify this a little before we input some values of t and x to find the value of c. 1 over 0.1. This is going to become minus 10 times k. All right. When this goes to the numerator, you can think of it like this. 1 over minus 0.1. Put that on your calculator. 1 over minus 0.1, that's going to give you minus 10. It becomes minus 10k into e raised to power minus 0.1 t plus c. This is what we have. Now we need to find the value of c. How do we do that? We put these two values, value of t and the value of x. We say when t equals 0, x is supposed to be equal to 20. Let's see what we get from that. ln of 20, that equals minus 10 times k into e raised to power 0 plus t. Okay. Now remember, you want your final answer in terms of k, so you can't find the value of k. C is also going to be in terms of k, and that's all right. Let's simplify this. It becomes ln 20 equals minus 10k plus c, and the value of c turns out to be 10k plus ln of 20. You should not be using decimals in equation, so you will leave this in exact form like this, ln 20, and that's all right. Now you write down that equation. This is what the equation looks like. ln x equals minus 10k e raised to power minus 0.1 times t plus c, which is 10k plus ln of 20. Okay, this is the equation that we get from this. That's what we wanted, but you can't leave it like this. You have to make it a single ln term, remember. Whenever you have multiple ln terms in your final result, you have to write down the final result as a single ln term. So what can we do for that? We can bring this ln to the left side as well. What is that going to give us? ln x minus ln of 20. Remember, they've not asked us to make any specific variable the subject. They just want a relation between x, k, and t. Okay? Anything could be the subject, or maybe you don't have any variable as the subject. Just make sure that you have a single ln term. All right. How do we make it a single ln term? We take the ln terms to one side, becomes ln of x minus ln 20. That equals 10k minus 10k e raised to power minus 0.1. You have just rearranged them. It's not necessary. It just looks better. Now on the left side, I have ln of x over 20 equals 10k minus 10k e raised to power minus 0.1 t, and that is our final answer. We leave it like this now. Okay. Always do this step. Sometimes they don't deduct marks for this. Sometimes they have 1 mark specified for this thing, making it a single ln term. Now, since you can't know before the exam, during the exam, whether they would have a mark for this or not, you should always do this. Always convert it to a single ln term. Okay, you should always be doing that. So it becomes ln of x over 20, that equals 10k minus 10k e raised to power minus 0.1 t. That's the result that you get from this. Okay. Now let's move on to the next part. Now it says, given that x equals 40 when t equals 10, find the value of t and find the value approached by x as t becomes large. Becomes large means as it goes towards infinity, okay? Let me copy this equation. This is what we have. So they want us to find the value of k first of all, using these values of x and t. So we say put x equals 40 and t equals 10 and see what that gives you. That gives you ln of 40 over 20. That equals 10 times k minus 10 times k e raised to power minus 0.1 into t, which is 10. Now let's simplify this. It becomes ln2 equals 10k minus 10k e raised to power minus 1. How do you find the value of k now? You can take k common on the right side, and that leaves you with 10 minus 10 e raised to power minus 1. On the other side, you've got ln of 2, and then k equals ln 2 divided by 10 minus 10 e raised to power minus 1. Now, they have not asked you for an exact value anywhere here. Have they? Value first? No. So they're not saying you want an exact value. So if you want now, you can also write this as a decimal. Let's see what that turns out to be. What's this value in decimals? ln2 divided by 10 minus 10 e raised to power minus 1. Okay, that's giving me 0.10965. So that will be 97. 0.1097. That's the value of k that I'm getting from this. Okay. Now we've got that value. Find the value approached by x as t becomes large. Now that we know that k equals this number 0.1097, what does that equation become now roughly? Now again, they're not asking us for an exact value. If they'd asked you for an exact value, you would leave this in exact form like this. But they have not asked you for exact value, so you can just keep it as it is. Let's just input that value of k here and see what that gives you. ln of x over 20, that equals 10 times k. What would that be? 10 into 0.1097, that's going to be 1.097, right? So it becomes 1.097 minus 1.097 e raised to power minus 0.1 times t. Now, what happens to x as t becomes large, as t goes towards infinity? What is going to happen to x? What's going to happen to x now? let's think about it. As t goes towards infinity, as t becomes very large, what happens to this thing? This thing becomes zero, right? E power something negative, e raised to power an extremely large negative value. What is that going to become? That will become zero, right? You can put a large negative value of t here in your calculator, and you would see that this value turns out to be very close to zero. Now, when that happens, it means ln of x over 20, that equals 1.097 minus zero, right? Because you've got zero, this whole thing becomes zero. And now you can figure this out. The base of ln is e, so it becomes x over 20 equals e raised to power 1.097. And now 20 goes to the other side, gets multiplied by that. You can see what this results in. E raised to power, the answer multiplied by 20. This is giving me 59.903. That's the value of x that we get from this. As t becomes very large, x approaches something close to 59.9. And that is what we were looking for. Is that okay?
Sir, for the value of k, do we give 4 decimal places?
Minimum 3 significant figures. That's the general rule for the whole paper. It's better to write 3. So if you want, you can write it as 0.110, but you don't get deduction for that. As long as the question statement does not have a requirement for the level of accuracy, you could write this as 110 if you wanted. But for using it here, you should be using a more accurate value. So you should be using 0.1097, minimum 4 significant figures for the next one. Okay. What value of t do we input in our calculator if you had to do this? Any large value. So put a very large value. So if you want to put this whole thing on your calculator, you can try, for instance, putting in your or in fact, just focus on this part, let's say, e raised to power minus 0.1, put a large value of t, 99999, as many nines as you want, and you would see the calculator is going to give you 0. If it gives you an error because the number has become very large, then you remove a few nines and then check if that works. Eventually, you'll get 0 at some point. Okay. To try with the very large value, if it gives you an error, try something slightly smaller. And you will get 0 for this. But you should also understand the logic, because sometimes they want exact answers for such problems. And your calculator will not be able to give you an exact answer. Okay, it'll only give you an answer in decimals. So you need to understand this logic as well, that as t becomes very large, what this means is e raised to power minus 0.1 t is actually the same thing as 1 over e raised to power 0.1 t. So if t becomes very large, this whole thing becomes very large. This goes towards infinity, and that's 1 over infinity, which is 0. So you need to understand the logic behind it as well. All right. But mostly, yes, when they have not asked you for an exact answer, the calculator thing is going to work as well. In most cases, in 90% of cases, that works. All right, let's move on to the next one. Okay, so question number 9, not many. If you have a problem with that, I'm going to skip that. It's just integration by parts, right? You'll have to apply integration by parts when you expand it. One term will get integrated directly. For this thing, you will have to use integration by parts, then just input the limits from 0 to this point. For finding this point, you'll have to put y equal to 0, and this point is going to turn out to be 3 here, right? 3 minus x equals 0, that gives you x equals 3. You'll input limits from 0 to 3 in the second part to find the shaded area. In the first part, you have to find this point. That's just differentiation. Put that equal to 0. You'll get that point. It does not look that difficult. Should be doable. Then question number 10 is partial fractions and binomial. Okay. All right. So this is the last question that you're asking about from this paper, question number 11. Let's have a look at this now. In the diagram, OABCD is a solid figure in which OA equals OB, and both of them are equal to 4 units. And OD equals 3 units. OD, okay, so OD equals 3 units. This length is 3 units. And OA and OB, these lengths are both 4 units. So you can actually write down the vectors OA, OB, and OD from this. OA has I direction, so you can say the vector OA, that equals 4 times A, right? I is the unit vector in this direction. If the length is 4, it becomes 4I. OB vector has a length 4 and direction J, so it becomes 4J. And OD vector has a length of 3 units and direction K, so that's 3K. These are the 3 vectors that we have. Now it says the edge OD is vertical. Okay, so OD is vertical. DC is parallel to OB. All right, now that looks slightly complicated. DC is parallel to OB, so that's parallel to this length here. Keep that in mind. This is parallel to this side. And DC is equal to 1 unit. DC is 1 unit. If DC is 1 unit, now it will help you later on if you keep writing down these vectors. DC is parallel to OB. That means it's in the same direction as OB. So its direction is basically J, and its length is 1. So that means the vector DC is 1 times J. That's just J. DC vector is J. Okay, 1 times J, that's J. Now, the base OAB is horizontal. So this base is horizontal. OD is vertical. Keep that in mind. Angle AOB is 90 degrees. AOB. So this angle is also 90. Now this angle is 90, and remember, OD is vertical. So the angle of OD with OA will be 90. Angle of OD with OB will also be 90. So all of these are 90 degrees angles, right? Because OD is vertical and AOB is horizontal. So keep that in mind. All right. Now, the midpoint of AB is M. You can see that in the diagram as well. This point is M. And the point N on BC is such that Cn equals to 2 times NB. Cn is 2 times NB. So if this length is 2, this length is 1. Now you see, it's a vector question with these ratios. It generally gets pretty lengthy. Again, a question not to touch in the middle of the exam. Okay, sometimes vector questions are relatively straightforward, like finding points of intersection, finding perpendicular distance, standard methods. You can just apply those standard methods and get the results. Sometimes it's more complicated, like this one, where you have to use ratios, etc. This is going to become quite complicated. Do not end up starting this in the middle of the exam, okay? Otherwise, you will be losing a lot of time. Keep this for the end. Okay, now, not always just this vector question, this type of vector question, because this is going to take longer. Sometimes you get an easier vector question. You should definitely do that. Do not skip that in the middle, because mostly the vectors questions are pretty standard, right? Finding points of intersection and stuff. You should be doing those in the middle of the exam as they come, basically. Okay, now how do you find these vectors? One vector that you have to find is vector MD. So you have to start at M and end at D. So from M, we have to go to the point D. Let's find a path on the diagram on which we know some vectors. We can go from M to A. Now we have to find this vector first. Then we can go from A to O and then from O to D. This is one possible path that you can follow. There could be other possible paths as well, but this is one possibility. Okay. In order to go from M to D, you can say, let's go from M to A and then go from A to O, and then go from O to D. Now, AO is known, that will be minus 4i. OD is known. The only problem is MA. Now, M is the midpoint of AB. So we can say MA is half of BA. If we consider this whole vector BA, MA is going to be half of that. So it's half of BA plus AO plus OD. And now what is BA? BA is basically OA minus OB, remember? Position vector of the second point minus the position vector of the first point, OA minus OB, plus AO plus OD. Now just write down those vectors and simplify them. That's 1 over 2 into OA. What's OA? O to A was 4i. So we have 4i here. Minus OB, that was 4j. Plus AO. AO will be negative of this. That's minus 4i. So you have minus 4i plus OD. OD is 3k. This is the vector MD. That was one thing that you were looking for. Let's simplify this. 4i over 2, that's 2i minus 2j minus 4i plus 3k. When you simplify this, that gives you minus 2i minus 2j plus 3k. That is MD vector. Okay, that is one thing that we were looking for here, the vector MD. All right. Now the second thing that you're asking us for is ON. So now on the diagram, we have to start at O. How do we know that the direction is BA and not AB? Because we are starting from M, right? We're going from M to A. From M to A, it's this direction, right? Towards the left side, MA. That's the vector that we're using here. What's the vector parallel to that in the same direction? It's BA in the same direction, starting from B, ending at A. So it's not AB, it's BA. All right, towards the left side. Okay. All right, that's the vector MD. Now the other vector that we're looking for is ON. So we need to start at O and end at N. Now, what path can we follow for this? We can say, let's go from O to B and then from B to N. This is one possibility, right? Let's do that. ON vector equals OB plus BN. Now, OB is known to us, that is 4 times J. The problem is BN. Now, since we know the ratio of these sides, we can say BN is the same as some number multiplied by the vector BC, right? BC in the same direction. BC is parallel to BN. So we can say BN vector is 1 over 3 times BC vector, right? Because we know the ratio. If this total length was 3 units, if that total length is 3 units, BN is 1 out of those 3 units. So we can say BN vector is 1 over 3 of this whole vector BC. Right? It's 1 over 3 times that vector BC. And now, can we find the vector BC somehow? What is BC going to be? Position vector of the second point, that's OC, minus the position vector of the first point, that's OB. Now, both of these vectors are known to us. We can say that's 4j plus 1 over 3 into OC. OC was, do we know OC? Okay, now we also do not know OC. How do you find OC? You can go from O to D and then from D to C. Let's write that down here. OC vector is OD plus DC. We know both of them. OD is 3K and DC is J. So OC is 3K plus J. Let's put that here. 3K plus J minus OB. What's OB? OB is 4 times J. Subtract that here. And that's going to give you the vector ON. Let's simplify this. That gives us 4J plus 1 over 3 multiplied by 3k minus 3j. Simplify this, and that gives you 4j plus k minus j, and it's 3j plus k. That's the vector ON. That's what we were looking for here. All right, make sense? Now that's a bit complicated, requires some practice, but once you practice this enough, it's very similar to O-level vectors. Basically, in O-levels, you used to have 2-dimensional figures. It's just that here you have 3-dimensional figures. Okay, you just have to find a path on the diagram that takes you from the starting point to the end point. Okay, so that's how it works. Now, keep in mind, mostly, not always, mostly when they ask you for vectors like these, the coefficients here are integers. Now, not always, sometimes they are fractions as well. That is possible. But mostly, these are integers. So if you're getting fractions, make sure to just recheck your working in case there is some careless error here. Okay? All right, now let's move on. Calculate the angle in degrees between the directions of MD and ON. Angle between directions MD and ON. Okay, so we found both of those vectors before. Now you see the next two parts are pretty standard, right? The next two parts are standard, but you can only do them if you get the first part correct, right? Now vector MD is equal to minus 2i minus 2j plus 3k, and the other vector ON, that is equal to 3j plus k. Okay, we need to find the vectors, the angle in degrees between these two directions. Just apply the angle formula. What's the angle formula? Cos theta equals A dot B divided by modulus of A into modulus of B. Just apply that formula. What's the angle? The angle here is cos theta equal to, in fact, you can just find those two things that we need here first. Dot product. What's the dot product? Let's find that dot product first. Just multiply corresponding components. It becomes minus 2 into 0. There's no I component here. Plus minus 2 into 3, the j components. Plus 3 into 1, the k components. A dot B turns out to be minus 6 plus 3, which is minus 3. That's the dot product. Let's find the magnitudes. For this first vector, I'm calling this vector A and this vector B for the formula. Now this becomes 2 squared plus 2 squared plus 3 squared, and then square root of that. This is going to be square root of 9 plus 8, which is 17. And then you do modulus of B and see what that turns out to be. Modulus of B is 3 squared plus 1 squared, and that gives us under root of 10. Let's input these values here. It becomes cos theta equals minus 3 divided by under root of 17 into under root of 10. Put this on your calculator directly. You'll get an obtuse angle for this, and that's all right. You can write this as an obtuse angle as well. That's perfectly okay. Or you can write the corresponding acute angle. Both of them are acceptable. Let's see what we get for this. Minus 3 divided by under root 17 multiplied by under root 10. And this gives us minus 0.23 something. Cos inverse of that, that's giving me 103.3 degrees. Make sure your calculator is in degrees mode here because the question requires your answer to be in degrees. Again, that's your final answer. Now it says, show that the length of the perpendicular from M to ON is under root 22 over 5. Perpendicular distance from a point to a line. from a point to a line. Remember the method for that? You just have to apply that standard method, all of that, and that will give you the result. Okay. Now, what do you need for that? You need the position vector of the point M. Do we have that? OM. We need the point's position vector, OM. Do we have that anywhere here? Well, we don't. We have to find the vector OM first. The position vector of the point M. We can say that's OA plus AM. OA plus AM. And then it becomes OA plus half of AB. AM vector is half of AB vector. We know AB vector. OA is, in fact, there's a direct way of doing this as well, by the way. I'll also show you that way. OA is 4I. And then AB is OB minus OA. OB is 4 minus 4I. 4J minus 4I. That's going to give you the result. It becomes 2I plus 2J. That's what OM turns out to be. A direct way of doing this could be, since M is the midpoint of A and B, you could use the midpoint formula as well here. Right? M is the midpoint of A and B. The midpoint formula. Let's see what that gives us. The direct way of doing this could be using something like this, that OM is half of OA plus OB, right? It's the midpoint of A and B. OM, the position vector of the midpoint, that can be written as half of OA plus OB. And that will also give the same result. OA was 4I and OB was 4J. And that also gives you 2I plus 2J. So you could also do it this way. Okay. Now we have the vector OM, the position vector of the point M. That's one thing that we wanted. We wanted distance from ON. Now let's think about this. Let's say this is ON. This is the line ON. And there's a point M somewhere. We need to find this distance, the perpendicular distance between that point and this line. Now for that, we also need the equation of the line ON. We need to find this equation somehow. Equation of the line ON. How do we do that? We need a point that lies on this line. We know the point N. What's the position vector of the point N? We found that earlier. 3J plus K. Now for equations, I prefer using the vector, the column vector form generally. That seems easier to me. So it's 0, 3, 1. And OM vector is 2, 2, 0. We've got the point M. Now, what's the equation of the line N? Line ON. What's the equation? R equals A plus lambda D. A means a point on the line. This is a point on the line, the position vector of a point on the line. That's 0, 3, 1. And now if you think about it, or you could actually also use origin, because origin is also a point. This is also fine. 0, 3, 1, you could also use this. But to make things simpler, in place of the point, you could actually just use origin, right? Because ON, the line ON, also passes through origin. So it's easier to just use origin here. So this is the point, R equals A plus lambda D. So 0, 0, 0 plus lambda into D. What's the direction vector? This is the direction vector. That's 0, 3, 1. A plus lambda D. That's what we're using here. That's the equation of the line. This turns out to be lambda into 0, 3, 1. That's the equation of the line ON. We've got the equation of the line ON. We've got the position vector of the point M. Now, what do we used to do after this? We need this point. Position vector of the foot of the perpendicular. Let's call this point something. Let's call this point X. What is point X going to be? The position vector of the point X. We can say OX vector. That's the position vector of the point X. X lies on this line ON. What's the position vector of the point X? The same as this line. And that will be 0 lambda, which is the 0, 3 lambda, and 1 lambda. This is OX. You could simplify this to 0, 3 lambda, and lambda. That's the point OX. And now we need to find the vector MX somehow, because vector MX is supposed to be perpendicular to the direction of the line L. And we would equate their dot product to 0. What's the vector MX? Let's find that. Vector MX is going to be OX minus OM. That gives us 0 minus 2. Or let me actually just write that. 0, 3 lambda, lambda minus 2, 2, 0. The vector MX therefore becomes minus 2, 3 lambda minus 2, and lambda. That's the vector MX. Now that we've got the vector MX, we say that MX is supposed to be perpendicular to the direction of this line. What's the direction of the line? ON. So now we can use that idea that MX vector is perpendicular to ON vector. Just put their dot product equal to 0. Minus 2, 3 lambda minus 2, and lambda. Dot product of that with the vector ON. What was the vector ON? The direction of the line ON. That's 0, 3, 1. This should equal 0, right? Because they are supposed to be perpendicular vectors. What do we get from this? Minus 2 into 0 plus 3 lambda minus 2 into 3 plus lambda into 1, that equals 0. And that gives us 9 lambda minus 6 plus lambda equal to 0. We would get a value of lambda from this, which is 6 over 10, and that's 3 over 5. That's the value of lambda at which the point X would be a perpendicular. Now, what we're looking for is this distance from M to this point X. This distance, that's what we're looking for. Now, we already have the vector MX. All we have to do is put the value of lambda in that. What does the vector MX become now? Vector MX becomes minus 2, 3 lambda minus 2 lambda. Let's input that value of lambda in this. Lambda equal to 3 over 5. What do we get from that? Minus 2. 3 into 3 over 5 minus 2. That's giving me minus 1 over 5. And then 3 over 5. That's the vector MX. Now you find the magnitude of this vector because that is going to give you that distance. What's the magnitude of this vector? Square root of minus 2 whole squared plus minus 1 over 5 whole squared. In fact, you can just use positive values as well if you want, because it doesn't make any difference. 2 squared plus 1 over 5 whole squared plus 3 over 5 whole squared. That is going to give you that perpendicular distance. Now, do they want an exact answer? Okay, so they want you to show that it's under root 22 over 5. Let's simplify this. 2 squared, that's 4 plus 1 over 25 plus 9 over 25, and that is 22 over 5. Inside the square root, you get 22 over 5. And that is what they wanted you to prove. That's the perpendicular distance. Now that's a standard method. You have to understand that very well. Finding perpendicular distance from a point to a line. It's complicated, but once you understand it, you just have to apply that same method on such questions. There's not much complication that comes, right? So this whole process of finding distance from a point to a line, you need to kind of just remember all the steps for this. All right. These are standard steps that we are using here, nothing different. And vectors questions are often quite repetitive in this sense. Part 2 and part 3 of this, parts B and C, 3 and 4 marks, although they were lengthy, there was not anything new here, right? They were pretty standard questions. The first part was a bit complicated, but nevertheless, it was quite lengthy. So you should mostly leave it for the end, especially if you get some ratios like this, because that makes things quite complicated. All right, I hope that makes sense. Now, unfortunately, today we won't have enough time to be able to discuss the other paper. Okay, so what I'm going to do is I'm going to postpone that other paper for our next class. And then along with that, we can keep another paper as well. So this was November 2022 paper 3-2. We also need to decide how to go about our next classes now, because most of the other papers you would find their recordings already in the playlist. So we need to decide whether we should keep going on backwards like this, as in do the 2022 papers next, and then 2021 papers, the difficult questions from them. 2020 recordings are not available. So we need to decide whether we should now jump to 2020 papers or keep going back like this. Like I posted some polls for the other groups for M1 and S1. I'll do the same thing for P3 as well. I'll post a couple of polls on the group to decide whether we should be doing 2020 papers live now or just keep going backwards like this. In that case, we might end up skipping some of the 2020 papers. So you will see what happens after that poll. But today, we will not be able to discuss the other paper, paper 3-2. The recording for that is also available, by the way. Paper 3-2, November 2022. I think the first 9 questions are already solved. And yeah, so these are the questions that you've actually asked about. The first 9 questions, all of them are available in the playlist already. You can have a look at that as well. And then we'll decide what we should be doing from next week onward. Our next class is on Tuesday. And then from Tuesday onward, we'll have classes every single day, inshallah. Okay. From Tuesday onward, we have classes every day. On Tuesday, we'll have our M1 exam. Since that's in PM, the Tuesday class will have to start a bit later, maybe around 7:20, 7:15. The Tuesday class will start late. We won't have an S1 class that day, only P3 class, or maybe I'll need to think about that, because if we start that late, is that an S1 day? Tuesday is an S1 day. Yeah, so we might actually not do P3 class on Tuesday, but then from Wednesday onwards, it'll be every day. Okay. But we need to decide whether we do 2023 papers after this or 2022 papers. I'll post some polls to basically decide that. Okay, I'm ending this class here, and I'll see you again in the next session then. Allah Hafiz. Laiba, you've seen the last part? Okay, good. All right. Allah Hafiz.